Hi everyone, welcome back. This is part 2 on the binomial theorem. As a quick refresher, a binomial is a polynomial with two terms. For example, x and 2, those are two terms. So these are polynomials, and sometimes we want to expand them, to multiply it all out into where you get just a big old polynomial. Sometimes it's easier to do when these exponents are small, but as we saw in the previous video, that can get fairly complicated, especially when that exponent is really big. So we have a shortcut. It's called the binomial theorem, and it's just a little sequence you can follow because these end up following a pattern, and so I'm going to explain that and do a few examples here. So I'm going to go through this first example, and then I'll kind of write down some steps and actually show you the formula as well. But let's just try an example first. I could do this fairly easily, but I just want to show you this with the binomial theorem anyway. So here's my example. I want to expand this out as much as I can. So here's how the binomial theorem works. The first thing you need to do is go to Pascal's triangle. And remember, we talked about in the last video, what you're going to do in Pascal's triangle is you're going to find the row that starts with the exponent right here. So since I have an exponent of 3, I'm going to go to Pascal's triangle. Here it is. And I'm going to find the row that starts with 1, 3. Those are going to be my coefficients for each of the new terms. So this row right here, 1, 3, 3, 1, I'm going to write that out. 1, 3, 3, 1. You're going to need a lot of space, so spread it out here. I maybe need a little more space. Then what you're going to do is the first term, x, I'm going to put an x in every single one of these new terms. And the second term, 2, I'm going to put one of those. Since it's being multiplied, I'm going to put in parentheses. We're actually almost done. All you need now are some exponents, and the way the exponents work is you start with the first term, in this case x, and the exponent on this one should match the original 3. So this 3 should go right here. And then the exponent on the rest of the x's is just going to go down by 1 each time. So since that was a 3, this will be a 2, this one will be a 1, that one will be a 0, and you should be to 0 by the time you're done. For the second term, the 2, I'm going to do the same thing, but backwards. Sorry, that's getting blurry. Same thing, but backwards. So the 3 is actually going to come over to this end, and then again, I'm going to just decrease by 1 each time, but go that way. So 3, 2, 1, 0. Again, I should finish up with a 0. This is basically my final expression. They're all just going to be added together. And now I just need to simplify, and that's it. The simplification is often what can throw you off, though. So this is all being multiplied together. 2 to the 0 is actually a 1. So I have 1 times x to the third, which is just x to the third. For the next term, I've got 2 to the first power, which is 2, times 3, which is 6, and then x squared. Remember that it doesn't matter what order you multiply all of these things, as long as they're in the same term. For the next one, 2 squared is 4, 4 times 3 is 12, and then I had an x to the first power, or just x. And for the last one, x to the 0 is actually going to go away and just become a 1, because anything to the 0 power is 1. 2 to the third power, that's 2 times 2 times 2 is 8. And now the question is, like, what do I do with all that? Remember, it was being multiplied. So you should multiply 1 times 8, which is just 8. Now that everything's all simplified, this is my final answer. So this is the expanded version of this. If I were to take x plus 2 and multiply it out 3 times, I would get this. Notice, well, here what I want to show you is So this is the formula for the binomial theorem. I know it looks complicated, but here's kind of what it's saying. It's saying if you have a binomial like a plus b to some random n power, you guys may have seen this E-looking thing before. That's a Greek sigma. It means sum. So it says you're going to do the sum, which is why we added them all together. And then this little thing here is called n choose k. It's something from probability or combinatorics. You might get into that in future math classes. Basically, we're replacing this with the row from Pascal's triangle. Then it says take your first term to the n minus k power and your second term to the k power. So basically, that's what we did, where we put the x in each of the terms and the 2 in each of the terms, and we did the whole thing with the exponents. So that's really all that's saying. So I know that looks like a big, scary formula, but it's actually not that crazy after all. Here's kind of the general steps that I like to think of, and if you want to write this stuff down in your notes, that might be a good idea. So the exponent tells you the row from Pascal's triangle to use. Then you'll start with the first term to the n power on the left and the last term to the n power on the right. Let's do a few more examples because I know that's kind of confusing. All right, we're going to expand this binomial, this time to the 4th power. Since it is to the 4th power, I'm going to need the 4th row. Well, actually, it's the 5th row in Pascal's triangle. It's the row that starts with 1, 4. Just to be clear, we would call this the 4th row. This is the 3rd row. This is the 2nd row. This is the 1st row. And we actually call this row 0, just because. Keep going backwards. All right, so we need the row that says 1, 4, 6, 4, 1. Okay, so I'm going to write that out. 1, 4, 6, 4, 1. Next, I'm going to put a 2x in each of these terms. I kind of need it to stay together, so that's why I'm putting it in parentheses, being multiplied by the number. And then I need a 1 in each of the terms. Everything's being added together. And now I just need some exponents. Remember, we're going to start with a 4 in this case. I'll start with a 4 and then go down from there. So 4, 3, 2, 1, 0. I'm also going to start with a 4 down on this end for the second term. So 4, 3, 2, 1, 0. And that's the expanded version. Just need to simplify. All right, work on our exponent rules here. Just as a reminder, if multiple things are in the parentheses, they both need that exponent. So not only am I going to do x to the 4th, but I'm also going to need to do 2 to the 4th power. That's 2 times 2 times 2 times 2, which would be 16. X to the 4th. 1 to the 0 is just a 1. And there's that other one as well, but all of that times 1 is just itself. Okay, moving on. On this one, I'm doing the exponents first because in order of operations, exponents is before multiplying. So do the exponents first. 2 to the 3rd is 8. X to the 3rd is x to the 3rd. 1 to the 1st is just 1. And then there's a 4. So again, don't add anything, it's all being multiplied. 1 times 4 times 8 is 32. Next, I've got 2 squared is 4, 1 squared is 1, and a 6 is just a 6. Then I can do 1 times 4 times 6, which is 24, and then x squared. Whew, a lot of exponents. Next one, 2 to the 1st power is just 2, so that's just 2x. that's still just a 4. And 1 to the third, be careful, 1 times 1 times 1 is just 1. So now, 1 times 4 times 2 is 8x. Over here, this one's actually pretty nice because anything to the 0 power is just a 1. 1 to the 4th is also just a 1. And some people like to say, oh, and that makes 3, but again, we're multiplying. 1 times 1 times 1 is just 1. That is my final answer. Everything's all simplified, so I have expanded this to get this.